Hello and welcome. You should be on page 16 of your Pre-Algebra Quarter 3 notebook. In this video, we're going to be talking about a transformation called a dilation. Now, unlike the other transformations we've talked about thus far, the translation and the reflection, which did not change size, a dilation actually does change size. And it's going to change sides because we are going to multiply our coordinates by something called a scale factor. And by doing so, we will create sides that are proportional. So what you should have is the same shape right here. Here's a small ABC multiplied by a scale factor to get a larger of the same shape. So when I am performing a dilation, I am going to multiply both the x and y values of each coordinate by a scale factor. And something to think about there. If my scale factor is greater than 1, my new image will be bigger. And if my scale factor is greater than 0 and less than 1, my new image will be smaller. So why don't you pause and make sure you write all that down, and then we'll start taking a look at dilations a little more closely. Welcome back. Here we go. Let's look at number 1. We're going to find the coordinates of a triangle after a size transformation with a scale factor of 2. So first up, we've got to find our original points. So let's look for A. I start at 0, 0 and go negative 1, 2, 3, 4, 5, negative 5, and up 1, 2, 3, negative 5, 3. B, I'm at 0, 1, 2, 3, and down 1, 2, 3, 4, negative 4. And C is at negative 1, 2, 3, 4, negative 5, and negative 1, 2, 3, 4, negative 4. So my scale factor is 2. So to find my A prime, B prime, and C prime, I'm going to multiply my X and Y coordinates by 2. X's and Y's by 2. So let's take a look. Negative 5 times 2 is negative 10. 3 times 2 is 6. 3 times 2 is 6. Negative 4 times 2 is negative 8. Negative 5 times 2 is negative 10. And negative 4 times 2 is negative 8. Now I'm multiplying by a number that is greater than 1. So I'm assuming that my triangle, my new image, will be bigger. Let's take a look. I want to plot my new points, and it doesn't look like they're telling me to plot it, but we're going to just so we see what it looks like if I have room on this. Negative 5, I know that's at negative 5, 6, 7, 8, 9, 10. And we're going to go up 6. 1, 2, 3, 4, 5, 6. A prime. Let's look at B. It's going to be negative 6. Positive 6. 1, 2, 3, 4, 5, 6. And it will go down negative 8. 1, 2, 3, 4, 5, 6, 7, 8. There's B prime. And C prime goes to negative 10, which of course I know is this line here from my A. And I'm going to go down to negative 8. Negative 1, 2, 3, 4, 5, 6, 7, 8. There's C prime. And indeed, it looks like I have a nice right triangle that is bigger. There we go. I'm sorry my line wasn't perfect. Let's take a look at our next one, which I am multiplying by a number that is between 0 and 1. So I'm assuming I'm going to get a smaller triangle. So first up, I have D, E, F, and G to find. So D is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. E is also at 10. It's at the same vertical line. Negative 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. G is at negative 1, 2, 3, 4, 5, 6, 7, 8. And negative 2. And F is also at negative 8. And it's at negative 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. I need to multiply all of my x and y coordinates by 1/2 in order to find. Now, if you remember, fractions are division, and 1/2 is 1 divided by 2, and 1 divided by 2 is 0.5. So I'm going to multiply all of these coordinates by 0.5. So let's get d prime. 10 times 0.5 in my calculator is 5. 8 times 0.5 is 4. E prime, I already found 10 times 0.5, it's 5. Negative 8 times 0.5 is negative 4. F prime, negative 8 times 0.5 is negative 4. And we've got negative 8, so we're going to have another negative 4. And G prime is going to be negative 4. And negative 2 times 0.5 is a negative 1. So I have all my new coordinates that I can now plot. So D prime is going to be at 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. There's D prime. E prime will be at 5, negative 4. 1, 2, 3, 4. F prime will be at negative 4. 1, 2, 3, 4. 1, 2, 3, 4. And G prime will be at negative 4, 1. So as I assumed, I was going to get a smaller version of the same shape. So let's take a look at our next page and see what we might want to explore further. So in this page, I'm not plotting anything. I'm simply finding the vertices after a transformation. So I have a scale factor of 5. So I want A prime, B prime, and C prime. I'm multiplying all of my x's and y's by 5. So A, 0 times 5 is 0. 9 times 5 is 45. I am glad I don't have to graph that. Even happier to not to graph negative 18 times 5, which is 90. Negative 90. And negative 9 times 5 is negative 45. 27 times 5 is 135. And 0 times 5 is 0. So now I have a scale factor. I've used 5 and I found 3 new points that I could plot. Now I'm going to do the same thing with the same points. Well, kind of the same thing. I'm multiplying now by a scale factor of 2/9. Now, something about 2/9, you got to be careful if you're using a regular calculator. That is a repeating decimal, so you can't just say, oh, it's 0.2/9 is 0.2 repeating. You can't just do 0.2 because you're going to not get a whole number. So you do need to put it in the calculator first as 2 divided by 9 and then do your multiplication. So I have A prime, I want B prime, and I want C prime. So, well, the nice thing about 0 is anything times 0 is 0. So 0 times 2/9 is 0. 9 times 2/9 is 2. Negative 18 times 2/9 is negative 4. And negative 9 times 2/9 is negative 2. 27 times 2/9 is 6. And happily 0 times 2/9 is 0. So by using our understanding of what dilations are, multiplying by a scale factor, we can find our new coordinates for our new shape easily. Last problems on this video, we are going to determine the scale factor. So one thing to think about first, here's my A, B, and C, and I'm looking at A, B, C prime. Definitely a bigger shape, so I am going to get a number greater than 1. Let's see what happens. If I look at A prime, it's 2, 1, and A prime is 4, 2. So let's look at my X. I go from 2 to 4. And my Y, I go from 1 to 2. 2 times what equals 4? Well, 2 times 2. And 1 times 2 equals 2. So it does look like my scale factor is 2. Just to be sure, let's look at my B. Negative 1 times 2 is negative 2. 3 times 2 is 6. So the scale factor of this is 2. I'm going to look now at this one, and it looks like I have A, B, C, D. It's a parallelogram. There might be a rhombus. I can't quite tell if it looks like a rhombus, all the same sides. And A prime, B prime, C prime, D prime. I've gotten smaller, so I'm going to have a number between 0 and 1. If I look at A, looks like A. Actually, I'm going to go with B because B is all positive, and then I don't have to be negative at all. So B, I go 1, 2, 3, 4. And up 1, 2, 3, 4. And B prime is 1, 2. Up 1, 2. Okay, so with this, I want you to think about the fact that multiplication and division are opposite operations, and we're going to kind of use that idea. So if I go for my x values, I go from 4 to 2. And y, I go from 4 to 2, both of them. So I'm looking at the same change. Now I know to go from b prime, I would multiply by 2. So that means in this case, I would divide by 2. So what am I multiplying by? I need somehow to divide by 2 to get my b prime. But I can also kind of recognize another pattern. I'm making this much longer than I need to in this video, so sorry. If I look at this one right here, if I were to put my new number over my old, right, my prime over the old, 4 over 2 equals my scale factor. 2 over 1 equals my scale factor. Let's see if I can get this here. If I put 2 over 4, 2 over 4, that equals 1/2. So let's see if I do 4 times 1/2, that does indeed equal 2. And I know 4 times 1/2 equals 2. So in this case, my scale factor is 1/2. And probably the simplest way, not just figuring out what you need to multiply to figure that out, is to put your prime over your original, and you will get your scale factor. That's it. Thanks so much.